Welcome to Lecture 32, Naïve Bayes, a powerful and fast probabilistic classification algorithm. I am Sparky and today we go from scratch to implementation. First, what does the name mean? 2 words, 2 ideas. Naïve means the algorithm innocently assumes all your input variables are completely independent of each other. Bayes refers to Bayes' theorem, the mathematical framework named after Reverend Thomas Bayes who lived from 1701 to 1761. Together, Naïve Bayes uses Bayes' theorem under a naive independent. Bayes' theorem is the heart of this algorithm. P of a given B equals P of B given A, times P of A, divided by P of B. P of a given B is the posterior, what we want. P of B given A is the likelihood from training data. P of A is the prior, how common is this class? And P of B is the evidence, the same constant for every class, so we can ignore it. Now the naive part in detail. The algorithm assumes all features x1, x2, x3 are independent. So instead of computing complicated joint probabilities, we simply multiply individual ones. P of x1, x2, x3 given y equals P of x1 given y times P of x2 given y times P of x3 given y. Take the sentence I eat mangoes, each word is treated independently. No dependency among features. That is the naive. Putting naive and Bayes together gives us the final formula. P of y given all features is proportional to P of y times the product of all P of 11 given y. The proportional sign means we dropped the denominator, it is the same constant for every class, so it cannot change which class wins. For multiclass problems, calculate this score for every class, pick the maximum. A quick refresher on probability, the foundation of everything. P equals favorable outcomes divided by total outcomes. Example, a bag with 3 yellow and 2 green balls. P of yellow equals 3 over 5 equals 0.6. P of green equals 2 over 5 equals 0.4 and for independent events, P of A and B equals P of A times P of B. This multiplication rule is exactly what naive Bayes uses. Conditional probability is the building block of Bayes' theorem. P of B given A means, probability of B given that A has already happened. The formula is P of A intersection B divided by P of A. Rearrange it and you get P of A intersection B equals P of B given A times P of A. Set this equal in both directions and divide, you derive Bayes' theorem. The maths connects beautifully. Why use naive Bayes? It is used for text classification, sentiment analysis, spam detection, recommendation systems and disease prediction. The assumption is no dependency among features, every variable is checked independently. Advantages, it is faster than most algorithms because there are no iteration loops. Just counting. It works well on small training data and is excellent for NLP and sparse data. There are 3 variants. Choose based on your data type. Bernoulli NB is for binary features, present or absent, 0 or 1. Used in sparse document data. Multinomial NB is for text data, word counts, term frequencies, TF-IDF vectors. For NLP, words become vectors and go into this model. Gaussian NB is for continuous features that follow a normal distribution, like medical measurements, height, weight. This is what we used today on the iris dataset. Step-by-step calculation, predict whether to play tennis. Features, sunny outlook, high humidity, weak wind. First calculate scores for yes and no. Multiply the prior by each conditional probability. Yes gets 0.0317. No gets 0.0686. No is higher, so the model predicts. Do not play tennis. This is the argmax, or implementation in sklearn is just 3 lines. Import Gaussian NB, create CLF equals Gaussian NB, fit on training data, predict on test data. And with the iris dataset today, accuracy score was 0.9667, which is 96.67%. Gaussian NB is the right choice. When your features are continuous and follow approximately. Quiz time. Question 1. Why is Naïve Bayes called naive? Think carefully, it is about an assumption the algorithm makes. Quiz time. Question 2. Which variant of Naïve Bayes should you use for continuous numerical features like height and weight? Remember the 3 variants we covered. Quiz time. Question 3. In Bayes' theorem P of A given B equals P of B given A times P of A divided by P of B, what is P of A called? Think about what it represents before seeing any evidence. Summary time. Naive means all variables are assumed independent. Bayes means we use Bayes' theorem for probability-based classification. Conditional probability P of B given A is the building block. 3 variants, Bernoulli for binary, multinomial for text, Gaussian for continuous data following normal distribution. Prediction. Always pick the class with maximum posterior score. Thank you so much for watching. Special thanks to Ajay sir for the teaching, and to my AI friends Smarty and Claudie for always helping. See you in the next lecture.